introduce our featured speaker, regardless of who it is and what subject. But today is unique. Many scientists spend their careers jumping from university to university, gathering titles. And, quite honestly, my own belief, if it wasn't for all the hoo-ha and misconception on global warming, most of them would be down in Berkeley or Santa Cruz reading tarot cards for adoring students. However, our featured speaker today did not spend his career in universities. He spent it in the field, in the trenches of commerce, all over the world. He is considered an expert in the field in which he's going to talk to us today. Through his many years, instead of acquiring degrees, he has acquired knowledge, he has acquired experience, but most of all, he has acquired judgment. To look at a situation, stand back and say, you know, here's what's really going on. And today he's going to share with us what is really going on. So let's give a warm introduction to Ted Gilbert. Now, this is going to be videotaped. It's going to be on YouTube. So it will be flashed around the world eventually. So Ted, you're a videographer. You know, I was born with a bad spelling gene, so Lori Mordun, right?
Yes.
Okay, mumble it fast and mispronounce it and it all comes out the same.
Thank you very much, Chuck. And Mr. President, I appreciate being able to be here as a former military officer, and as such I want to say to all of you, thank you for service. And now we get down to the meat on the subject here. Global warming is being tossed around now, and it is causing a bunch of confusion. There's more people that have come up with various ideas. To go over a few things before we get started here, I'd like to go back to some high school words and all, really. The subject involves mainly carbon and oxygen for a C and for an O, and you'll see them on the slides. There's also methane, and there's other natural gas and other things that come into play. But looking at this up there right now, below global warming, I have anthropogenic. Is anybody familiar with that? That is one of the problems. That is one of the problems. Anthropogenic means man-made or caused by man. Myself, why, I know that there's global warming and global cooling. There's warming when the sun comes up, and there's cooling where the sun goes down. There's warming in the summer, and there's cooling in the winter. So when people say, well, I don't believe in global warming, well, you have to be careful of the words. What we need to say, the words we need to use are anthropogenic or man-made. Below that, why my name, and you'll notice that 14 February, that's written military style. I still do that. I like to put the day before the month. And below that is the seal of the American Association of Petroleum Geologists. Now, I need to make clear that I do not represent the AAPG. A few years ago, why there was a little note sent around to all the members of the AAPG saying, what should we do about this global warming? I voted, as the majority of the members, to just cool it. The reason is, and you might say intimidation, but when you're looking at getting leases offshore and doing business with the government, you have to be very careful with this administration. There's something that some people say, it's called crony capitalism. Well, in light of that, why I'm speaking here for me and my main mentor, who is Dr. Lee C. Gerhardt. And you can find him on the internet. He's been around for many years. And in the field, I used to send him samples from the drilling operations. And he had students and himself, and they would analyze them. And some of the data that he has used in the slides that you'll see were from some of the wells that we drilled. The way they analyze it and everything, why they come up with all kinds of things, and they have instruments that you wouldn't believe. And so we know an awful lot about what has happened. So anyway, now I got to find the clicker. Where is it? Here we go. This is geologic data after Scotese and Bernard. And it first appeared in 2005 in the Explorer, which is the AAPG bulletin. And on this, you can see that, I hope you can see, up on the left side, there's Cambrian. And the black line starts there at 542 million years ago. And at that time, when the sediments were deposited on Earth, they left various, shall we say, footprints. I don't like that word, footprints. And so the analysis shows that just under 5,000 parts per million CO2 was in the atmosphere, and it went up to about 7,000 parts per million CO2. And it comes across and it comes down, and then there at the Carboniferous, normally in the United States we talk about the Mississippian and Pennsylvanian. And the European way is usually to say Carboniferous. Well, it's all the same thing. But during that period, why there were tremendous forests, and the forests require carbon. Everything that we have on Earth that is edible or usable by animals, or animals themselves, our foodstuff, are all carbon compounds. Sugar is a carbon compound. Starch is a carbon compound. And at that time, why the coal deposits in Pennsylvania and in the UK, the big coal fields, were all formed. Right there, you can see that that blue line is the temperature. That's the average temperature on Earth. And it looks like a straight line there, but actually there's a bunch of dots. In doing the analysis, well, it was a bunch of dots, but you put it on the computer, and you add them together, and you divide it, and you come out, you can see there's pretty much a straight line along the top of those blue lines. And right there at the Permian, why you're coming out of the period where the tremendous forests, the dinosaurs were going strong, they're getting built up, And then you have there the Triassic and then the Jurassic. And they talk about there was something dynamic that happened at the KT boundary. A lot of people feel that's when a meteor hit the Earth, and some people feel it was in the Caribbean area. Anyway, the analyses of that KT boundary are many minerals that are not normally found any place except in meteorites. So, to me, it's a very interesting history that's put up there. The blue line, you see, comes over here at where it gets the green. Well, it goes from the orange to the green, and the temperature starts coming down. And that blue line is actually at about 22 degrees centigrade. Well, they say Celsius now. I'm still old school and I say centigrade. But anyway, it's all the same thing. But you can see that blue line comes down there, then it jumps up, then it jiggles, and it comes down. And right now, the temperature is down at about the coolest point that it's ever been as far as the average global temperature. Now, there's land and there's sea and there's mountains and everything else. That's taking the average. So we're in a period now, and we've been in there for about 63 million. If you want to say 67, I won't argue. But it's been a long time. And so we're in global cooling, and as such, why we're in a unique position with our carbon dioxide, which is a black line. It's down there right at the minimum it's ever been. And it's running about 380 or in that range. Now, something I'll point up right now is in Atascadero, why we had a meeting with the city council and people, and I gave a little talk about some of the global warming things. And after me, this PhD from Cal Poly came up there, and he said that I didn't know what I was talking about. That when the CO2, now he said CO2 content reached about 380, human life would be in jeopardy. And that stunned me. I didn't know what to do. I mean, how could a man like that, that's a PhD and an instructor at Cal Poly, come up with that? And I thought about it. I didn't get up and answer because I was stunned. Anyway, a little while later, why it hit me, he was a little confused. He mistaked CO2 and CO. CO is carbon monoxide, a deadly poisoning, completely different than CO2. Because at about 380, why carbon monoxide is very dangerous. At about 400 parts per million, why you can die. But there's confusion on a lot of these things, and what people like Al Gore and Dr. Jim Hansen, who got his PhD in astrophysics, and actually that's what I was interested in to start with. That was the way I started out with my engineering courses and everything, is go into astrophysics. But my uncle convinced me otherwise, and I was interested in the military, so I took the military approach at that time. But Jim Hansen wanted to get a grant. And Al Gore being the vice president, why Jim Hansen approached him so he could get this grant, so on retirement, why he could study CO2, earth temperature, and these type of things. Now, I'd like to read something to you here because it's kind of long and it's confusing. But when you have a person saying something that is a pure imaginary thing, it's called a hypothesis. And a hypothesis doesn't need any facts. You can just state it, and it's a hypothesis. Then you could work on trying to prove it or whatever you want to do. When you do have some proof, why, it becomes a theory. And what Al Gore with his book, and his, what was it called?
An Inconvenient Truth.
Yeah, that's it.
Movie.
Why, that was a hypothesis. And there's in there, why most people say there's 39 falsities in there. Of course, they usually say lies, but I don't like that word really. But anyway, let's go back here and I'll see if I can. Okay, in 1896, and this is a tough one, a man by the name of Archenius Saventi wrote, and it says, on the influence of carbonic acid upon the temperature of the ground. And that was in 1896. He actually knew what was going on, and this was published, let's see, London, Edinburgh, and Dublin Philosophic Magazine and Journal of Science. 5th series, page 267. And what is really interesting about that, he stated at that time that if CO2 was, pick a number, say 200, and you double that to 400, it would have a tremendous effect on raising the temperature. But if you took 400 and doubled it, there'd be almost no effect. It's a reverse logarithmic type of action. Adding CO2 right now, and it's about 380 last I looked. Why, if we doubled it, there wouldn't be any effect that you could see. It'd be so minute. But I think that's interesting that long ago. Actually, we've known about that for years, and then it went on through the 1920, I think in 1922, the New York Times, or was it the Washington, well, one of those newspapers, published about global cooling. And then there was warming and cooling and so forth and on. And then in, what year was it? In 2004, that Jim Hansen wrote a paper stating that we're all going to succumb to global warming. And Al Gore picked up on it, and I think it was in 2006 that Inconvenient Truth was published. And so anyway, we can move on here off of this. And my friend Dr. Lee Gerhardt published this thing, and it has been updated and all since then. I mean, when there's new information, Scotese and Berner update the graph, but whoop, I went too long. Okay, here we have that a lot of the people now that are the alarmists, they look at this, and this is actually in central Greenland. But they're saying that these ice cores are telling the story. And right over here on this very edge, can you see a little upturn? That's a little warming. But they're saying that's the proof that we're in are moving into global warming. Come on now. That's, you know, that's really stretching it. But that's one of the things that they use. And so, but anyway, this goes back 15,000 years, and well, from right now, right here where 0 is, going back, you can see the temperature fluctuation and all. And the cause of that, of course, is the sun. The sun is the reason we have warmth. And the difference between Earth and, say, Mars is that we have water, CO2, and we can grow things. And the greenhouse gases, if we didn't have any greenhouse gases, in probably about 72 hours, if we could eliminate magically all greenhouse gases, in about 72 hours, we'd be about 40 degrees below 0, right here. We have to have greenhouse gases. It's very important for many, many reasons. Now, the greenhouse effect, this is kind of hard to read, but essentially it's talking about the sun. The sun, the rays come down and there's infrared and so forth, and some of them are bounced off of the upper layers up where the Concorde flew, and that was usually about 53,000 to 55,000 feet. That Concorde, and that at the speed they were going, why that skin would get very hot. So there's still quite a bit of atmosphere up there at 55,000 feet. Some of it's reflected, then it hits the ground, it's reflected, and then down below, why that's the infrared that's bounced off of the Earth. But that's the general idea of what's happening and is being called the greenhouse effect. Now, Dr. Gerhardt, in his work that was published in 2005, he used this graph. And this is looking at that whole pie chart there is the atmosphere. And the water vapor, part of it is the red. The green is because of a material coming from plants and biology, volcanoes, this type of thing. Cattle, of course, with their double stomach, why they do belch things up and create some methane. And methane actually is very slight, and we'll show you that in just a minute. But right here now, the human additions part of the atmosphere that he looked at, and you'll see some other numbers that'll be similar, but different researchers sometimes get a little bit higher, a little bit lower numbers in their studies. This is came from the United Nations, and they're looking at the upper pie chart, which is nitrogen, which is most of the atmosphere. And then the oxygen there, the O2, is at 20.9. And that's the real critical figure. Where do we get our oxygen? Where does it come from? It comes from CO2. And everybody that's an alarmist wants to get rid of CO2. It's extremely important. We have to have it. Looking down here, you can see this smaller light blue pie chart with CO2 at 0.035 is what they came out with. And then there's some little bitty slivers down there. And there's neon, helium, methane, CH4, and hydrogen, krypton, and various other things. But when you look at the whole situation here, the atmospheric components, CO2 is really very small. Now this also was from some of the United Nations work. And this, they're just looking at what they call the greenhouse gases, and this is what they alarm people with. Showing that carbon dioxide 84%, methane 9%, nitrous oxide, fluorinated gases, and all. And so that looks much more critical there. And let's see, where am I here? I had a note, I think, made about that. So there's ways of scaring people, and like a few gentlemen have said in the administration, you never want to let a crisis go to waste. If you don't have a crisis, make one.
That's right.
So that to me says a lot right there. That's what is being attempted. Now looking at this one, why they start down there on the left at 1480. That was many, then there's 1520. And you can see the main heavy line is the majority of time. And when it goes up, why, it's warming. When it goes down, the blue goes down, that's cooling. But you have warming and cooling and warming and cooling and warming and cooling, and it comes up to about 1960 on here. So the sun effect is constantly changing. And that's not caused by man, that's caused by the sun. This is not, like it says up there, well before atmospheric CO2 began to increase. And it was increasing because of manufacturing and all throughout the world. So now we go on. The clicker here, there we go. Now this is essentially the same type of thing done by a different researcher, and it starts only at 1900, the year 1900, and it comes up, and it goes up and down and up and down, and it's a little warming there till about 1940. Then at 1940, where there's cooling, up and down, and then there's a little bit more warming from 1980 up to there about 2000. And then there's cooling, and this cooling mainly is projected and a guesstimate, relying on computer information and all. But now look up at the map. Up there, you can see United States in the black right up there, and then there's South America, and there's a little bit of red in there. Just right about, that's, well, from Panama down to probably Ecuador. It's a little warmer there, and there's some spots up over here by Greenland and all where there's some warming. But now, the IPCC, and I never can remember all these things, but that's the United Nations group, international or intergovernmental panel on climate change, IPCC. But the IPCC, or the United Nations, objective, it seems, through Agenda 21 and various things, is to paint the United States as the bad guy. And you can look, and this starts at the left, and that is right now. And you can see there's a little upturn in that red see, we got global warming. When you look over here, and from the ice cores, which I think is just blowing smoke, but anyway, you can see how the temperature is going up and down and up and down and up and down, primarily due to the sun. And that little upturn there, I'm sure it'll be going down, it'll be going up and down, and with the weather we're having right now, why everybody's thinking about, well, we got global cooling now. Actually, looking at meteorological data goes back about 200 years. And when you look at just what's happening right now, why, I mean, as far as I'm concerned, this polar vortex stuff and all that, I mean, that's more smoke and mirrors. And you can argue about it, and sometimes people want to argue with me. Well, really, this is not my data. I didn't come up with it. My friend Lee Gerhardt feeds me stuff, and I got an email from him this morning. I told him I'd be talking to a group about global warming. He came back and he said, good luck.
We're on your side.
So, anyway, now this is from Blumely. Dr. Blumely, he's mainly studied in Europe. And what I wanted to point out with this is that you can see back there at where the line starts is 542 million years ago, or in the Cambrian, that the CO2, and this is relative and all, went up a little bit like it did on that earlier chart, and then it comes down here at about 300, and that's during the Carboniferous, when all of the plants were growing and everything. So CO2 comes down, then it jiggles up and down, and it comes down here to the present time, which is there at 0. So essentially, to me, that a different researcher in a different area and analyses of different samples, I think tells a good story to me. Now here is another chart that was made up by Blumely, and the thing that I think is interesting here is that at the Pleistocene, it starts down there just about 60 million years ago, and that's when the cooling effect really began to build up. And there's a straight line, well, it's a curved, smooth line, I should say, and that matches. Then you get over here, you can see those lines going up and down like that. Well, we have gajillions, if I can use that term, of examples down here in the Pliocene to the recent time. And actually, where that smooth, lighter blue line is, it's probably going like that, but we can't pin that down to the extent that we can here. So right now we got warming, cooling, warming, cooling, warming, cooling, warming, cooling, warming, cooling, and cooling. So it's it tells another part of the story that I think is real important. This comes from the North Carolina Department of Agriculture. Actually, this was made up for children. But in North Carolina, they're at least being taught the truth. Here it says non-mineral nutrients are hydrogen, oxygen, and carbon. And I like to say non-metallic. It gets on later on down into your potassium and all your various nutrients that plants need. But the process called photosynthesis. And plants must have CO2 to provide photosynthesis, or taking the sun's energy and converting the carbon dioxide into sugars and starches. And I really can't emphasize that enough, but you have to make sugars and starches. For cattle feed, my dad used to always go out, and when he'd have times like right now and buy hay, he'd take out of a bale or whatever, and he'd chew on it. And if you've ever done that with hay that's been dried and baled properly, it has a sweetish taste. That's plant sugars. So good hay must have CO2. And like last year on my barley field in front of my house, well, the barley got up about that high. Well, the CO2 was very low. And the rain was very low. And I could go out there, and I did go out there a few times, and just plucked off some of the dried up barley, chewed on it. It didn't have a sweet taste. Didn't have enough carbon dioxide. You must have carbon. And carbon, if carbon was soluble, why, your diamond rings would melt. And if you've had charcoal briquettes and you've barbecued and all, and you throw them out on the ground, why, they'll stay there a heck of a long time for practical purposes. Now, people can argue about that, but for practical purposes, carbon is not soluble. And again, you can argue about that. Oh, yes, it is, but you know, it's so slight, it doesn't make any difference, and it really, spreading carbon on a field doesn't help. But if you burn it, if you burn gasoline, fossil fuels, you get the carbon dioxide, and carbon dioxide is a very heavy gas. In relationship to air, it's about 1.5 times as heavy. And I was working on a project about a year ago in Colorado at the Trapper Mine. The Trapper Mine is an open pit coal mine. And they take that open pit coal, they scoop it up, and then they burn it to create steam and run their generators. And coming out of these big old smokestacks, and when I was up there, it was about 7 below to 10 below zero. But you can see this white, smoky, well, there was water vapor and everything in it, and it coming out, and it'd go right down to the ground. It was mainly CO2. And it went down, and with a light misty rain or snow, the CO2 is highly soluble. And like we had, what was it, a couple of weeks ago, we had these little rains that were misty rains. That scrubs the CO2 from the atmosphere. And these city councils and these people that are going by the AB 32 and this type of thing, and they want to lower the CO2, all we need to do is get some slow, easy rain. And that will do it. It comes out, and it goes to the plants, and it grows, and we have fruits, vegetables, everything we consume today, it's carbon compound. Now here, this is mine. Well, I shouldn't say it's mine. I got it from the national, atmospheric and all charts. But I pulled it out, and you can blame me for this. If you notice over here, South America, you can see there's a kind of a dot. The Galapagos Islands are where all these semi-prehistoric type critters are living, and these big lizards and everything else. Right in there, why, there's a crack that goes almost straight across to New Zealand. And it's where the plates, and of course this is pretty much a theory, but the plate tectonics is talked about in almost all literature that's talking about the geologic history. Well, the overlap right there, you can see that little red line? You see that all right? That's heat. And the Navy ran some ships out there for the National Atmospheric and Oceanic, whatever it is, group. And they found some temperatures in certain areas of that crack that were down about 30,000 feet, and the temperature is right at 400 degrees. But they noticed there was something moving. I don't think they ever got any pictures of it, but there was something alive down there. 400 degrees. Hard to believe, but that's like many things. It's hard to believe. Okay. Now, what's that? That is hot water. That's about 9 degrees hotter than it was. I'll go back here. There, well, there's no real surface heat, but there, it's so hot down there where those plates come together, and hot water, of course, rises. It comes up, and that's that thick red area. Hot water, you put a pot on the stove, and when it's cold, why, the pot will probably sit there all day, but you turn some heat under it, or another pot, and the hotter it is, the faster it evaporates. In order to have rain, you have to have moisture, atmospheric moisture, or available moisture to make clouds. Seeding, this type of thing, does no good unless you have clouds. Seeding could be used. The Chinese used it before the Olympics in China, and they were very unsuccessful with it. But it's been tried and worked on and all, but it's the seeding. The best thing is if we could help it warm up out in the Pacific Ocean. And the reason that helps us is there's the trade winds, and I'm sure you all remember about the trade winds and the prevailing westerlies and all with the sailing ships and this type of thing. But that hot water and the atmospheric moisture comes right up into California. And you say, well, why is it raining so much up in Oregon and Washington and going across the United States? That's a Japanese current. The Japanese current is coming up from Japan, and it comes up there, and the water's warm, and there's atmospheric moisture up there. If we could move the Japanese current down, why, we could get some more rain here. But I don't think that's in the future. But anyway, that I think those two pictures tell a real good story about the El Nino effect. And the reason I got interested in it, we were working on some wells down in Talara, Peru, and I've always liked fish. And the fishing boats would come in and talk to these old fishermen. And one old fisherman, why, he had a string and a thermometer hanging on the end of it. And he was saying, yeah, yes, sir, you know, it's real good fishing, good fish, give you a special deal today, all these type of things and everything. But I asked him, what's the difference right now? He said, well, senor, he said, this is very good for us, the El Nino effect. He said, the water is 9 degrees warmer than normal. And so that's what got me started at looking at some of this stuff. We need global warming, and we can't get it with CO2. The sun is the main source of our energy. And right now, many scientists think that the sun has used up about half of the hydrogen. And so now our sun will probably go into a nova or supernova in, oh, say, 1 billion or 2 years. So I don't think I'll be around then, but anyway, it's kind of fun to look at. Now here's another interesting thing. They were talking about, well, the polar ice cap is melting and all this kind of stuff. Well, this year right now, the last figures I saw were that the North Polar ice cap was 30% larger than it's been in years. Up here, you can see where these lines come together. The North Pole is right up there. And where that yellow line comes down there, that's what's called the Gackel Ridge. G-A-K-K-E-L Ridge. Something happened up there that geologists a few years ago would say, oh no, it'll never happen. There's no way that molten lava could come in at 3,000 meters in depth. Well, it did. And I think right now why it's calmed down. But Al Gore said, oh, that's not going to have any effect on it. Well, you put molten lava below the North Pole at about 2,700 degrees or 2,400 degrees, anyway above 2,000 degrees, you put it underneath that polar ice cap and it's going to have some effect. No way it cannot have effect. And that can affect the polar ice cap, and right now why that Gackel Ridge isn't very effective now. And of course there's Greenland down there. And we all know from some of the history and all that Eric the Red, wasn't it, or one of those people had planted vines and growing grapes in Greenland. That was in a period of warming. Now this, you probably remember the airplanes going from the United States to UK and all, the volcanic ash. That's Iceland down there. And that's coming into the atmosphere. This atmosphere we have is a miraculous thing. It can handle things like Krakatoa, Iceland, all the particulate matter and everything going into the atmosphere. But with our trade winds, with our atmosphere the way it is, it can handle it. There was no lasting, drastic effect, and that's a lot more stuff going in the atmosphere than from tailpipes of automobiles. And that's something that really I should talk about, I think, now. The way these people are talking about the CO2 content, the only way you can check CO2 that I know of is with a Draeger tube. Got it, Chuck. I'm running out of time here. But they put out these figures. Well, that CO2 is so many thousand metric tons and all. You can't check that by any test that I know of. It's a calculated figure. And what they're doing in Pasarola is they're counting how many automobiles are registered, and then they calculate this and that, and they come up with tons per year. Well, that's as phony as anything else. Try and do that at Tascadero too. Now here, this caused as much trouble as anything. The poor old polar bear. You know what he's thinking right now? He's thinking, I wonder if that camera and that thing holding that camera is edible. And polar bears, one record that I read about, was able to swim 250 miles. A lot of polar bears swim 200 miles. So, there goes. And this is, I'm ending up now, but if you've ever looked at the Hubble telescope pictures, or if you've seen something like this, and I've seen the midnight sun from the North Slope, but I've never seen it with a moon like that, and I don't know if this is a true picture or not, but to me, that indicates that there's a power much greater than man. Thank you.
back to slide 1 and locate on there the beginning, the earliest indications we have of life and then primates. Is that legitimate?
Okay, Chuck?
Yeah. Let's have a brief question and answer period here. This fascinating presentation by Ted would normally be several hours long. So let's have some quick questions, and as in the past, please resist your enthusiasm to have a question be a 10-minute speech. So let's have several.
Okay.
Yeah.
Okay.
And
Did you hear my question? My question was, on this chart, would he locate our earliest indication of the origin of life, number 1, and the rise of primates, number 2?
Over here, right in there, is where the first life began. Trilobites, and then graptolites in the oceans, and then coming on over into here, why it was mainly vegetation. But then, let's see, where are we here? Right in here, at about 350 million years ago, 360 million years ago, is where the amphibians, the dinosaurs started coming about. In the tremendous forests and all that made, well, in some places, why coal seams are 600 feet deep, or thick, I should say. 600 feet thick, and that takes a lot of plants and a lot of CO2. And it ate up the CO2, and it came down here, and there was still a warm earth, and then
the dinosaur extinction is where?
What, the KT?
Dinosaur extinction is what.
The Jurassic.
Okay, that's, where is it here?
After the Jurassic.
KT, the KT boundary, right here. Now, dinosaurs were diminishing in here. Many of them were dying off, and it wasn't really good, the temperature and everything for dinosaurs. But right here at the KT boundary, and it's amazing, there were some of the sea life died off, and for all practical purposes, the majority of the large dinosaurs died off. But many of the mammals, like the saber-toothed tiger and all, they came through it. They came through it. And some of the mastodons came through it. But that was a drastic change, and that's the one where you can find these, it's only about that thick when you see it throughout the United States, the KT boundary. But there's like ash and this type of thing, and minerals that are found in meteors. So you can analyze it and find the KT boundary. And
several people have asked me to ask you a question, and where do you think this whole thing on climate change, global warming and all that, where do you think it's heading in the years down the road?
Well, I think right now that the Brits are starting to understand, and Americans are starting to understand. And I have a couple good references from the UK, The Guardian, and some of these magazines and papers that are very socialistic, that they're coming out with some articles saying that, well, East Anglia University that was built in Norwich was built mainly to add strength or add a technical base to the UN's IPCC hoax that's being thrown at us, and we're being penalized based on ignorance and stupidity. Is that too strong?
All right. Okay, we have time for 2 quick questions before we make a presentation of a brand new Porsche.
Well,
I have a question.
Yes.
We're talking parts per million. Do we know the volume, volume of our atmosphere?
Of the solar
Do we know
atmosphere?
the volume of the atmosphere of Earth? Can we measure that?
Yeah, we have calculations on that. I can't tell you off the top of my head. But the CO2 being as heavy as it is, and I don't know, but there's a fella here that has his PhD in chemistry that I've argued with, but the CO2 in the air, you can't figure it on the whole atmosphere because it's heavy. He says, well, winds are going to stir it up. Yeah, but like you mix vinegar and oil. And if it slows down a little bit, why? The vinegar goes down, the oil floats to the top. And the CO2 goes down to the ground where it can be leached out of the atmosphere by a slow, misty rain. But I think I can dig up the figure if you want to know the volume of the atmosphere, but
I was trying to make it relative to the parts per million issue, and what is the volume of our atmosphere? But you made clear that you can't just do that because it's very small.
yeah, it settles down and it doesn't tend to go up. Of course, you can get in, and there's some people start talking about the isotopes of carbon, and you can get into all things. There's a Dr. Thomas Goro that's all into these carbon sinks and this type of thing, which amount to a pinpoint. And there's people who are going to be arguing about these things, and if it's your religion, and that's what this global warming is, it's more like a religion than anything.
Okay, one more question. Yes, make it a brief one.
I keep reading that the scientists, quote unquote, about 75% of them, or maybe higher, go along with this global warming. Forget Gore, because they make fun of him. But these are scientists, and they call the people who don't go along with them deniers, like the Holocaust deniers, and then you're ignorant. How do you overcome this? You said little by little understanding's coming. Is it getting out there that these scientists are off base, or what?
Well, if I may use a term, I'll try to put it in words that are not too offensive, but male bovine scatology.
Yes.
Yes.
Yeah, yeah. But now I have some references if you would like them, and I think Chuck is planning on putting it in your bulletin. But where is it here? There's one real good reference, and it can be found if you use XQuick. I don't use Google. I don't like Google. I don't like who they support. But anyway, I use XQuick, and it's Climate Science International. And the head of it is Tom Harris, and he's in Canada. And he's a top-notch individual scientist. But there's a list of 289 technical scientists that don't go along with it. And the group that I'm in with Dr. Lee Gerhardt, there's 79 of us. And most of us are in this Climate Scientist International, as well as Fred Singer and Tim Bell and what's Lindzen? Lindzen, I think, was originally, he's a sharp cookie from MIT, and he has tore them up. There's also a Gerrit von der Lingen, and I met him in The Hague, and I'm surprised he's still alive. He's in his 90s. But that guy, he can cut you off at the knees. I mean, he's tough. Eloquent speaker, but he's brutal. And he's a denier. He's not an alarmist.
So there's more out there than we realize. The media just doesn't talk about it.
Yeah.
Ted,
Yes, sir.
can you come up here, please?
Thank you.
Would everybody give Ted a hand? That was,